the statement made is incorrect. It is not safe or compliant with the National Electrical Code to run only 3 wires, line 1, line 2, and neutral, from a meter and circuit breaker combination to a house and then connect to the ground system at the panel while simultaneously keeping the ground and the neutral isolated. Here is why. The National Electrical Code, or NEC, requires that a grounding electrode system be installed at each electrical service and connected to the grounded, or neutral, conductor at the service panel. Isolated ground and neutral conductors can create a potential difference between the ground and the neutral at the panel. This can lead to electrical hazards, such as electrical shocks and also electrical fires. Without a proper grounding system, fault currents may not be able to flow safely to the ground, increasing the risk of electrical shocks and potential damage to equipment. The distance from the meter and circuit breaker combination to the house panel does matter. The voltage drop over the conductors must be within acceptable limits to ensure proper circuit operation. If the distance is too great, the voltage drop may be excessive, causing problems with appliances and electronic equipment. The correct way to connect a house from a remote meter and circuit breaker combination is to run 4 wires. Firstly, line 1, which is the first hot wire. Secondly, line 2, which is the second hot wire. Thirdly, neutral. Fourthly, ground. The ground conductor must be connected to the grounding electrode system at the house panel and bonded to the neutral conductor. This ensures a safe and code-compliant electrical system. It is important to understand the requirements outlined in the National Electrical Code, specifically regarding grounding and bonding. The NEC provides detailed guidelines to ensure electrical systems are installed safely and correctly. Understanding the code requirements is crucial for preventing electrical hazards and ensuring the safety of people and property. Grounding and bonding are 2 distinct but related concepts in electrical systems. Grounding refers to connecting electrical equipment and systems to the earth, providing a path for fault current to flow back to the source. Bonding involves connecting various metal parts of an electrical system together to create a low impedance path for fault current. The grounding electrode system typically consists of 1 or more grounding electrodes, such as ground rods, ground plates, or underground metal water pipes. These electrodes are connected to the grounding conductor, which runs back to the service panel. At the service panel, the grounding conductor is connected to the neutral conductor, creating a single point where the ground and neutral are bonded together. This bonding point is essential for providing a safe path for fault current to flow back to the source, tripping the circuit breaker or blowing the fuse and de-energizing the circuit. Without a proper grounding and bonding system, fault currents may not have a clear path to flow, which can result in dangerous voltage build-up on metal parts of electrical equipment. This can create a shock hazard for anyone who comes into contact with the energized metal. In addition to safety, proper grounding and bonding also help to protect sensitive electronic equipment from damage due to voltage surges and electrical noise. A well-designed grounding system can help to dissipate these surges and noise, preventing them from damaging the equipment. The size of the grounding and bonding conductors is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of these conductors based on the size of the service entrance conductors. It is important to use the correct size conductors to ensure that they can safely carry the maximum fault current that may occur. In addition to the grounding electrode system, other metal parts of an electrical system must also be bonded together. This includes metal conduits, metal enclosures, metal water pipes, and metal gas pipes. Bonding these metal parts together creates a low impedance path for fault current, reducing the risk of electrical shock. Bonding is typically accomplished by using bonding jumpers, which are short lengths of wire that connect the metal parts together. The bonding jumpers must be sized appropriately to carry the maximum fault current that may occur. It is also important to ensure that all connections are clean and tight to provide a good electrical connection. When running conductors from a remote meter and circuit breaker combination to a house, it is essential to use the correct wiring method and materials. The conductors must be sized appropriately for the load they will be carrying, and they must be protected from physical damage. The NEC provides guidelines for selecting the appropriate wiring method and materials for different applications. The conductors should be installed in conduit or other approved raceway to protect them from damage. The conduit should be properly supported and secured to prevent it from sagging or pulling apart. The conductors should be pulled through the conduit carefully to avoid damaging the insulation. When making connections, it is important to use the correct type of connectors and to ensure that the connections are tight and secure. Loose connections can cause overheating and potentially lead to a fire. The NEC also requires that all electrical work be performed by qualified and licensed electricians. These professionals have the knowledge and experience to install electrical systems safely and correctly. Hiring a qualified electrician is the best way to ensure that your electrical system meets all applicable codes and standards. In addition to the NEC, local codes and regulations may also apply to electrical installations. It is important to check with your local building department to determine what codes and regulations are in effect in your area. Following all applicable codes and regulations is essential for ensuring the safety and reliability of your electrical system. Voltage drop is another important consideration when running conductors from a remote meter and circuit breaker combination to a house. Voltage drop is the decrease in voltage that occurs along a conductor due to the resistance of the conductor. Excessive voltage drop can cause problems with appliances and electronic equipment, such as dimming lights, reduced motor performance, and malfunctioning electronics. The amount of voltage drop that is acceptable depends on the application. For general-purpose circuits, the NEC recommends that the voltage drop not exceed 3% at the farthest outlet. For branch circuits feeding sensitive electronic equipment, the voltage drop should be limited to 2% or less. The amount of voltage drop that occurs in a circuit depends on several factors, including the length of the conductor, the size of the conductor, the current flowing through the conductor, and the temperature of the conductor. To minimize voltage drop, it is important to use the correct size conductor for the application. The NEC provides tables that specify the minimum size conductor required for different current ratings and distances. It is also important to keep the length of the conductor as short as possible. If the distance between the meter and the house is long, it may be necessary to increase the size of the conductor to compensate for the voltage drop. Another way to reduce voltage drop is to use conductors with lower resistance. Copper conductors have lower resistance than aluminum conductors, so they will result in less voltage drop. However, copper conductors are also more expensive than aluminum conductors. It is important to consider the cost of the conductors when making a decision about which type to use. In addition to the size and type of conductor, the method of installation can also affect voltage drop. Conductors that are installed in conduit will typically have less voltage drop than conductors that are installed in free air. This is because the conduit helps to dissipate heat, which reduces the resistance of the conductor. When calculating voltage drop, it is important to consider all of the factors that can affect it. There are several online voltage drop calculators that can help you to perform these calculations. These calculators take into account the length of the conductor, the size of the conductor, the current flowing through the conductor, and the temperature of the conductor. By using a voltage drop calculator, you can ensure that the voltage drop in your circuit is within acceptable limits. In summary, when connecting a house from a remote meter and circuit breaker combination, it is essential to follow all applicable codes and regulations, including the NEC. This includes running 4 wires from the meter to the house, including line 1, line 2, neutral and ground. The ground conductor must be connected to the grounding electrode system at the house panel and bonded to the neutral conductor. It is also important to consider voltage drop and to use the correct size conductors to minimize voltage drop. By following these guidelines, you can ensure that your electrical system is safe and reliable. Always consult with a qualified electrician if you have any questions or concerns about electrical installations. They can provide expert advice and ensure that all work is performed safely and correctly. Remember that electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazard. Understanding electrical safety principles and following safe work practices is crucial for preventing accidents and injuries. Always de-energize circuits before working on them, and use appropriate personal protective equipment such as rubber gloves and safety glasses. If you are not comfortable working with electricity, it is best to leave it to the professionals. A qualified electrician can handle any electrical task safely and efficiently.